So today we're going to go over lesson 6 of our trig graphs unit, and this is going to look a little bit more at applications of these trig graphs. So I do have a warm-up for you guys, and I want you guys to take a second, pause the video, and try these first 3 questions, just determining the amplitude, frequency, period, and range of the following 3. So here are the solutions for the do now activity. And when we look at these, our amplitude is our number that's in front of the sign. It's always the absolute value of that. So that's why our A value is 4. Our B value is what's in front of the X. And again, we want to factor out that and make sure that inside those parentheses there is a 1 in front of our X. Our period, again, is 2 pi over that B value, so 2 pi over 3. And to find our range, again, we take our midline, which in this case our midline was 3, and we want to add and subtract our amplitude, and that's how I get my maximum value and my minimum value. So that is why our range for this first example is -1 to 7. So take a second and just look over the next 2 questions just to make sure that you got them correct. So today's lesson, we're going to start looking at the general form of our trig equations again. And we talked about this a little bit yesterday, that this coefficient in front of our x here, inside the parentheses, needs to be 1. And if it is not 1, then we need to actually factor that out so we can accurately find our b value, and so we can accurately determine what our shift of our function is. So if we look at these functions, we want to write this equation in general form. And we know that it's not in general form because we do have a 2 out in front of this sign inside of the parentheses. So I do want to factor that out. I'm going to have y equals sine of 2. And when I do factor that out, I do want you to divide each of these by 2. And when I factor that out, I'm just going to be left with x. And then plus pi divided by 2 is just pi over 2. So this is our function in standard form. And we also want to determine now what my shift is. So now that I factored it out, now I see that I have a shift going to the left, pi over 2 units. If we looked at this before, I would have seen this plus pi and think that it was going to the left pi units. But again, I need to make sure that I am checking that my value in front of the x is a 1. So this would be a shift left, pi over 2. So just take a look at another example. Again, I have this 4 out in front of here, and this needs to be factored out so that it is in standard form. So if I rewrite this, I'm going to have y equals. Now my amplitude is not changing at all. I didn't affect that. I don't need to factor out anything with that. That stays the same. But now I do have to factor out this 4. When I factor that out, I'm left with x minus. Now, because I do have this pi over 2 here, I do need to do some side work to determine what this actually is going to be. So I'm going to take my pi over 2, and I'm going to divide that by the 4, since I want to factor out that. Now, dividing by a 4 is the same thing as multiplying by its reciprocal, so I could absolutely multiply by 1 over 4. And then I would get that value is pi over 8. So when I factor out that 4, I end up with my pi over 2. Now that I'm in general form, and I know that I am in this general form because I do have a 1 in front of my x in my parentheses, I now determine that I have a shift. Since this is a negative sign, I'm now going to have a shift going to the right, pi over 8. Again, if I looked in my general form, I wouldn't be able to determine that shift until I factor it out. And always, whatever is inside of this parentheses, I always do the opposite. So even though it was a negative, I'm really going to the right, that pi over 8 units. At this time, I want you to pause the video, and I want you to give a try for number 3 and number 4. So take a second and just look at examples 3 and 4. Again, we want to factor out this divided by 2, same thing as multiplying by 1/2 on both my top and the bottom. I get that value of pi over 4. When I factor out the 2, that's what I'm left with inside of those parentheses. For the next examples, we want to state the period of the following equations. So in order to find my period, I take 2 pi and I divide it by my b. In this equation, my b value is this pi over 2. So to find this period, I'm going to take 2 pi and divide it by this pi over 2. Again, dividing is the same thing as multiplying by its reciprocal. So I can multiply this by 2 over pi, canceling this out, and multiply this by 2 over pi. To multiply these, I'm going to multiply right across. So 2 pi times 2 would give me 4 pi, but then again, I'm dividing by this pi, so my pi's cancel out. And I would end up with a value of 4. So let's think back to what our period actually is. Our period is our length of one cycle. And when we're graphing these, we take our period, and to find our critical value intervals, I take my period, and I divide it by 4. So in this case, I would go 4 over 4, because that's what my period was. And I would get that my critical value interval is 1. Meaning that I'm going to hit, and this is a sine curve, so we know that this is what my curve looks like. And I'm going to hit these critical values after 1 unit. Now, usually, the examples that we've been looking at, we've been labeling our axes in terms of pi. So pi over 2, 2 pi over 2, and so on. Now, when we're looking at applications of our graphs, it's going to make a little more sense to have an x-axis that are actual integers. So maybe we're talking in terms of time, and it makes more sense to have a time of 1 second as compared to a time of pi over 2 seconds. So when we're looking at these, and you look in your equation, if you have a b value that is in terms of pi, our period is going to end up being an integer number. On the reverse side, the equations that we have been doing, we had a b value that was an integer, and our period ended up being in terms of pi. Now it's just the opposite of that. Okay, so I want to look at one more question like this. So again, we're stating the period, and I know that my period is 2 pi over my b value. In this case, my b value is pi over 6. So I'm going to do 2 pi over that pi over 6. Again, to get rid of that fraction in my denominator, I can multiply by its reciprocal. Multiply by its reciprocal. Cancel out on my bottom. My pi values cancel out, and I end up with 12. So my period in this case would be 12. I want you guys to take a second and try the following examples on this page, and then I will put up the solutions for it. So if we just take a second to check our works for 7 and 8, and to find my period, I'm doing 2 pi over that b value. And then my other 4 down. Okay, so next we're going to look at actually writing the equations for some graphs. So the first thing I like to do is identify all my information that I need to write this equation. So the first thing I notice is that I'm starting at a maximum value. So I know that this is going to have to be a cosine graph. Next thing I want to do is determine what my amplitude is. So if I look, my midline is at my x-axis. I did not shift up or down for this graph. So I can just count what my amplitude is, and I go up 6 units. So my amplitude is going to be 6. I now also need to determine my b value. Again, if we look at this, we're now going to be looking at real-world applications, and our x values are in terms of time. So it makes sense that I have 1, 2, 3 seconds, 4 minutes, whatever the question says that it is. But it makes more sense to have these values than to have in terms of pi on my x-axis. So in order to find what our b value is, I can use what my period is. So if I look, my period is my length of one cycle. So if I draw in one cycle, I see that my period is 3. So I can set an equation to find my b value, and I'm going to say that 2 pi over b, I know that's how I find my period, it is actually 3. Now, in order to solve this, just put this over 1. I have that 3b is equal to 2 pi, divided by 3 on both sides, and I would get that my b value is 2 pi over 3. Again, in this case, my x-axes are labeled with whole numbers, so my b value is going to be in terms of pi. Now, when I write this together as my equation, I know that it is a cosine graph. So I'm going to have y equals, my amplitude goes in front, so that is 6. I know it is a cosine, and my b value is 2 pi over 3. And this graph is in terms of t, so instead of x, I'm just going to put a t. And this is my equation for 3. I'm going to take a second and try this next example. Again, determining my amplitude, finding my b value, and then putting it together as an equation. So if I look at this graph, again, I know that this is a cosine graph because I'm starting at its maximum point. I can determine my a value, and to help me find my b value, I want to see what one cycle is for my period, and I can see that that is in 1 over 36. So I set my period 2 pi over b equal to that, cross multiply to get my b value of 72 pi. And then just finally putting it into our equation. At this point, I would like you guys for practice to try questions 11 through 14, and then check back on the video, and I will have the solutions posted. So here is our solution for number 11. And here is my solution for number 12. Here is my solution for question number 13. And finally, my solution for question number 14. So that was our lesson for applications of trig functions. At this point, I would like you guys to try your homework, which is homework number 12.6, which will be due tomorrow. So